When your OEE increases, you haven't really gained much yet. You have to decide whether to put that into more output volume or whether you're going to use that to reduce costs. And how does that then work actually? Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's video, it's on a topic of how do we actually value OEE and what can we do with it? Because OEE is a main KPI in much of manufacturing, but quite honestly, OEE is pretty worthless by itself, right? There is, of course, a good reason why OEE is such an important KPI everywhere. Although I will also say that, in my opinion, most higher level managers put too much stock on OEE, forgetting what it is really about. So let's dive into that in this video. And first off, let me just show you what I drew up here so that you understand the OEE sort of picture and how to interpret it. I have a nice and simple OEE example with my full bar being 24 hours and then having availability, performance and quality. These three are all losses. So availability has things like planned maintenance, but also the unplanned breakdown. It has things like cleaning and product changes, stuff like that, right? You know that your machine will not be available. And that, by the way, is why I don't really like breakdowns being in there, but they are an availability loss, just an unplanned for availability loss. Then the performance losses. Well, this is basically speed, although you've also got companies that, for good reasons again, split it up into speed and short stops. The difference being that speed is just when your line is going slower, basically every minute of its production, and the short stop is when the machine just stops for a short, usually less than 2 minutes amount of time. And then you've got your quality losses, any product that you did get through the line but just defective, and you basically wasted the time as well as the resources. Now, those are the main categories of OEE loss, and then of course we've got effective time as well, which is what we want, right? This is the OEE percentage, and here it's roughly 35% or something like that. Then on the right-hand side, we also have a factory, or better, one machine or a line, that has technically the same OEE. And you might say, hey, but wait a minute, this is only, what, 20%? Something like that. Yes, and that has to do with these different levels of OEE. And when you really take 24 hours, we usually call it the TEEP, right? So the total effective time. With that, you then start counting from here, and you say, when the machine is manned to begin with, you basically have the same distribution as here. But this already does show us a very important thing. So there is this block of time in which this machine isn't even planned to be doing something. So it's not just not planned to be producing, but it's also not cleaning or whatever. This is a line that's probably off in the weekends, and even a bit more. That's a bit more than 40%. So that usually happens when you don't really have enough market demand to fill this line. And that is going to be a very important thing going forward. So are we producing what the market wants, and then, actually we cannot even serve them? So if we would have another line or more OEE on our existing lines, we would be pushing more into the market? Or are we already in that situation where we could easily, and we can actually, we're currently easily producing what the market demands? So any extra capacity isn't really needed. You can still save money through costs, but these are different things. And let me also take a quick moment there to say that if you want more of a deep dive on this, I have got a full course out on how to calculate savings, how to report savings and costs, and this OEE thing is a major part in that course as well. So go check out my site where you will find my course on how to calculate and report project savings. Very important skill for any CI engineer, and basically anyone in improvement. So what we now have, if we do an improvement of the OEE, so we squeeze some of these losses out, what are we going to make, right? We have fewer availability, performance and quality losses. We have at least the same amount of materials that we're making, but then Are we going to fill that extra time up with more production towards the market? Or are we going to go sort of to this situation? And that is the big difference with volume versus cost reduction, right? Now, to understand where this goes, there is a financial concept that we really need to understand, and that is the concept of fixed and variable cost. See, you've got your fixed cost. Those are things that you're going to pay no matter how much you produce. Then you've got your variable cost. Those are the costs that really scale with production. So, examples of these. Fixed cost, the buildings that you have. Fixed cost, probably management, right? Of course, if you really reduce production, you'll probably reduce management as well, but basically your management and your support departments, they don't really depend on your production volumes. Then variable cost. Materials is the first customer for this, right? So materials that you use in your production process to make your actual product, they are absolutely variable. Energy is a bit of a tricky one. So if you put energy into your product, so to say, so for instance, where you see this a lot is in smelting, making steel, making glass walls, drying things, heating and cooling. Those are very energy intensive processes. If they are needed to produce your product, then most of it is just going to scale one-on-one with the amount of product that you make. But the energy to keep your conveyors running, or the air conditioning of your building, or things like that, they are fixed or semi-fixed. They're a bit, they don't scale directly with the product. So then that's semi-fixed indeed. Those are the ones that sort of fall in between. And I would say that in most organizations, labor is a very good example of a semi-fixed cost. So for instance, if in this scenario we're going to be producing more, we're going to want to have more production. So we basically want to be in this here situation. That means that we are just going to plan in more hours as a starter, right? That's the easy switch we can toggle. And we will be also working in the weekend. So we're introducing more labor, more of that semi-fixed type of cost. And when we reduce, there's the other funny thing. So if we go from this situation to that situation where we don't really know yet, labor hasn't reduced yet. They're just idling here for 6 hours a day. So what are you going to do? Are you going to really send them home? Then you capitalize, you monetize the potential saving of needing less machine time by reducing your labor cost. Some may argue that this is not the goal of lean, and I do agree, although if it makes business sense, you should not be paying more people than are needed to produce your product. But that means that it's not a direct link, right? So if you can reduce the amount of time you need and then also reduce how much labor that costs, yes. Other things are, if you are going to reduce these costs, then so these time sinks, they are not linked with your variable cost at all. And that too is an important part. So this one, the variable cost, and let me just put that one with the green, it just has a direct link to the amount of product that you make. So your effective time, basically, because that's just the amount of product you make divided by the blade speed of that machine. Then the fixed cost, well, the fixed cost, they are also directly linked to how much you make. Why is that? See, the fixed cost, of course, they do not change, but we are talking about the fixed cost per unit when we are talking about how much it sort of costs our product to be produced in our factory. So both of those, they link with the effective time in a very different way. See, when you increase the effective production without having to increase, your 24 hours, then you reduce your fixed cost. So that one goes down. The variable cost goes up. So I should be, in total honesty, I should be saying, no. It's this one is going down. So the fixed cost, they stay the same. The fixed cost per unit is going down. And the variable cost will go up together with the volume, because the variable cost per unit stays the same. Now, semi-fixed has a similar idea to this, but what you see there is that it depends on what is that semi-fixed cost. So what is its variability? If it is labor, then it truly depends on the gray area. If it is sort of half production liney thing, then it depends on where it is. Does your line draw a lot of power while it is making non-quality items? Oh, you betcha. When it is in poor performance, you betcha. When it is being cleaned or when it is in plant maintenance, maybe not, right? So it depends on your factory situation. So that one, the semi-fixed, it is mainly linked to the gray bar. And let's put a nice color here. Mainly. But that one is always the tricky one. Now, there is something to really look out for when you are calculating these sorts of what does it give me. And that is a financial concept that we know by its acronym COGS, which stands for cost of goods sold, basically production cost. And what do our friends in the finance department always like to do? They will take the budget for the next year or the annual operating plan, but they will take the budget for the year and they will just put all of these costs and divide it by the budget volumes. And how do they get to these costs? Well, fixed is fixed, semi-fixed is full of assumptions, and the variable amount is because they know how much variable cost you have per unit times the budgeted volume, and then the whole thing is again divided by how many units or whatever volume you have, and it makes a cost of goods sold in so many dollars, pounds, rupees, whatever, per product, per 1,000 products, per liter, per unit of production. But this thing has all of them in it with more or less fixed coefficients. So if you see any of your improvement team, project team, problem-solving team calculations be based on this here friend, the cost of goods sold, or the sales margin, because that's basically if you have your sales price minus cost of goods sold, you get the sales margin, be very aware, because you're almost guaranteed not calculating your savings or extra earnings potential in the correct way. See, if you increase your volume, then the fixed costs don't change, right? The semi-fixed are usually linked again sort of to how many hours you spend. So if you can reduce this and increase your effective time, semi-fixed will do the same as the fixed. Per unit it will go down. The variable cost will not. But that means that if you say, well, we're going to take the sales margin when we increase our volume, you're ignoring this brilliant effect of this staying the same. Now you need the contribution margin, which is not a very popular thing in most finance departments, because we're not allowed to make budgets out of them. We're not allowed to hand it out too much between factories. So if you're not allowed to sell products per se within larger corporations on a contribution margin because it's way under market price. It's all kinds of financial reasons why they don't like to talk about it. The disadvantage of that is that they also don't talk about it when they should be. And that is when you're increasing the volume with the same resources. So things like that, how to really calculate, how to get into the whole thinking and then decide, what's my OEE worth, but also what is my material loss worth if I reduce it in scrap or defects. What do I do when I actually reduce them fixed costs or reduce a bit of labor? So there are some tricky parts in that. For that, I suggest go and check out that savings course that I made for you. I think it is a brilliant course to just have as a basis. If you are in any way in charge or directly linked to the program management of improvement stuff within your organization, so you're in finance, controlling, you're a CI manager, or you're somebody who is like a project leader for improvement stuff, you need to know this stuff, right? Now, if you work in a bit larger organization, your finance department probably has a bit of a rule book on this already, but most often you will not be able to understand those rules unless you know what they mean. So that is what I try to explain in the course that is now live. And actually, in all honesty, I mean, I priced it rather moderately. It's also sort of a nice thank you if you just like all of my videos and want to support this channel. But really, apart from that, this is basic knowledge that any CI manager or improvement team leader or industrial controller has to know. So check that one out and know that I already gave a nice part of it away here. Think about the difference between fixed, variable, and that sort of spooky category of the semi-fixed cost. COGS is not your answer. You want to know what is the effect going to be on my total earnings minus my total expenses. And if you have that way of thinking, you can really calculate what OEE gain does for you. And don't always assume that you can sell more product. That comes from your sales department and your planners as well, right? So for now, I wish you the best of luck actually improving OEE to begin with. And as always, don't forget to also enjoy the continuous improvement journey.